What's up, you data friends? It's Yanis here and welcome to my channel. In this video, we are going to go through an XGBoost machine learning example where we are going to use some bank data, the data of their customers, in order to predict whether they are going to churn or not. And more specifically, we are going to follow this process over here. So we're going to start by loading our raw data. We are going to go over data pre-processing, so data cleaning, dealing with missing values, aggregations and visualizations. We are going to go through the data modeling phase, so feature importances, running machine learning models, HyperParameter tuning, and also storing our models and our results. And then we are going to go through the development phase, which is basically building this Streamlit app from scratch, where the user can actually input their values for all of these features we have used in our machine learning model. This is going to send the data into our machine learning model and actually make a prediction whether the user is going to churn or not. And it's also going to give you the predicted probability of the churn. We also have the feature importances plotted over here, so the user can see the features that actually make a lot of difference. We are also going to develop a Power BI dashboard, which is this dashboard over here, where we have all of our predictions on our existing customers. So we can actually see whether the customer is churn or not, and also the customers who haven't churned yet but actually have a high probability of churning. So the business can actually do something about it and avoid losing all these customers. Right, going back here, and before we start this video, let me just say that if you're passionate about data analytics and data science, then please click the like button, subscribe to my channel, and enable notifications for my future videos. Right, starting with the first thing we have is the machine learning process, which is the process we are going to follow for our model. So we're going to start with problem formulation. So what questions are we trying to answer? Then we are going to load our raw data. We are going to go through our data pre-processing steps. Then we are going to split our raw data. Then we are going to run our models. Then we are going to evaluate our models. Then we are going to do some hyperparameter tuning. Then we are going to repeat this process until we find a model that we are happy with. And then we are going to store this model and then use it to build our Streamlit app and also have our predictions in a Power BI dashboard. Right, moving on, the problem formulation. So the questions we are trying to answer is that we are trying to understand which factors influence churn the most. We are also trying to identify individuals that have a high probability of churning. So this is what we do in the Power BI dashboard. And we also want to build a churn prediction model, which is the model that our app is going to call based on the user inputs. Right, going back here, now we're going to start by loading our raw data, and our raw data actually comes from this Kaggle page over here. So you can actually go in this page and download this data set. You can see all the columns over here. So I've just downloaded this file and I'm loading it into raw data and I'm displaying the first 5 columns. And as you can see, our Y variable is going to be this exited column over here. 1 means that the customer has churn and 0 means is that it's a return. So it's not a churn. Right, starting with our data pre-processing, we are going to try and understand all of our data. So what this code does is that it goes through all the columns in our raw data. It calculates the unique elements within each column and it stores this into unique values. Then it calculates the length of these unique values. And if the length is less or equals to 12, is actually going to print all of these unique values. Otherwise, we just want to return the length of the unique values, which is the number of different values you have in each feature or column. So as you can see, we have 10,000 rows and 10,000 customer IDs. So we do not have a duplication in customer IDs. Then if you check, our categorical columns are geography, which we have 3 different countries, gender, we have 2 genders, tenure, we have 11 different tenures, and then number of products, we have 4 products, and then has card is a 0 or 1, is active member 0 or 1, and also exited 0 or 1. The next step now is to check if we have any null values. So if we run this, you can see that we don't have any null values. So Kaggle actually made us a favor here that we don't have any null values and we don't have to do anything about it. Next step now is to visualize our data. And I always like to start with a count plot in order to check if my data is balanced or not. So what do I mean by that? If my y variable is not balanced, maybe there is some things we can do in order to balance our data set more and achieve better results. So as you can see from this count plot and our y variable, which is exited, we only have about 2,000 people that exited and 8,000 people that did not exit. So this is actually an imbalanced data set and it's going to impact our machine learning prediction. So I'm going to show you a few things we can do to counter this. Next, I am just limiting the data in order to create these pair plots and visualize my data. So in the limit, I'm just excluding things like the customer name, I think, and I'm also excluding the row number. So I'm excluding this, and then I'm visualizing our data into pair plots. So if we run this quickly, there we go. You can see we have all these pair plots, and we also have hue equals exited, which is our target variable. So the ones that are interesting, I would say, is this variable over here, credit score with age. So as we can see clearly over there, we have a lot of churns. Then maybe this variable is actually very good, which is credit score with number of products, because as you can see, there are clear distinctions on people who churn or not. Maybe this variable over here, age with, estimated salary. Yeah, I think that's it. That's the insights we can gain from these pair plots. Next, I don't need this pair plot over here. We want to investigate all of our features, which is basically the categorical variables, the ones that are not numeric, by our y target variable, which is exited. So this code is basically creating count plots per feature by our target variable, which is exited. So if we run this quickly, and then I'm going to expand this, we can see we have a lot more data in France, but actually we have a lot more people exited in Germany. Then geography, then if we scroll down, gender, not bad. Then over here we have age. Yeah, we can see that we have the churns over here, and anything more or less, I would say over here, they are not really churn customers. Age, let's see. Yeah, not bad. Tenure. Yeah, we can see that when the tenure is 3 or 4, we don't really have any exited customers. Then number of products. Sorry, this is tenure over here at the top, and then this is the number of products, which is basically a very good predictor, because if you have 3 or 4, you only have a few churns. Then we have has card. Yeah, not bad. Then we have is active member. Yeah, I mean, you have to bear in mind that this is not a balanced data set, so this does make an impact when we are visualizing our data. Right, moving on, we want to investigate the distribution of all numeric values. So over here, I am selecting all the columns that have a data type in this data type. So it's basically all the numeric columns are stored into n variables, numeric variables. And over here, I have a loop that plots a box plot per numeric variable, and also it prints the mean over here. So if I run it quickly, we can see this is the credit score, and then the box plot. Did it not finish? Let me see. Yep, like this. We have a few outliers over here, but I do want to keep them in because I don't think they're outliers. They are just people that have less than 400 credit score. Age, a few outliers. These are the old people, but it is possible to have a customer that has age 90, so it's not an outlier. Then tenure, fine, balance, number of products for past card, nothing, yeah, nothing exciting over here. Right, the next thing we're going to do now is that we are going to prepare our data frame, so we're going to be able to feed it in an algorithm or apply calculations on it. So the first thing I do is that I turn my categorical variables into numeric representation. So all of these are categorical, and what this is going to do is that it's going to create new columns based on the possible options we have in each one of these features. So geography, I think, has 3 options. So if I run this, you can see that for geography, we have geography France, Germany, Spain, and then true or false depending on the data of the customer. And the next thing I do is that I scale my numeric columns. So I'm using min max scaler, so 0 to 1, and then I'm applying this transformation only on my scale variables, the variables I want to scale. And this is basically our data down here. Right, now we have a data frame that we can use it to train any model. In our case, we are going to use XGBoost. So make sure you have these libraries installed and loaded. The first thing I do is that I split my X and Y. So Y is my target variable exited, and then X is all the features I'm going to use to train my model. Then I'm using holdout validation method. So I'm going to use 20% of the dataset to test my model and 80% of the dataset to train my model. Here I'm initializing my XGBoost classifier, and I'm using logarithmic loss as my evaluation metric. I am going to try different metrics you're going to see later down. Here I'm just feeding my model. Here I'm making predictions on both train and test datasets. Over here I'm calculating the accuracy. Here I'm just printing the accuracy. Here I'm creating a new data frame that's going to have the feature and then the feature importances. Down here I am just plotting the feature importances, and over here I'm just displaying the data frame that has the feature importances. So if I run this quickly, we can see that we have a training accuracy of 96% and a testing accuracy of 86%, which means that is actually good. That's what it's telling us, at least. However, we have to check the confusion matrix, which has recall and precision, to see if we're actually doing well. Over here, we have a bar chart with the feature importances, so the most important features. And down here, we have our data frame that has the feature importances. Down here is where we get the true results of our model. So this function is actually creating a confusion matrix and it's plotting it in this heat map you see over here. So it takes as input the confusion matrix, and then it plots this heat map you see down here. And in order to calculate it, first we have to calculate the confusion matrix. So we pass the Y test and Y test predictions, normalize true, store it into CM, and then we are plotting our heat map. And as you can see over here, we do a very good job in predicting people that are not exiting, but we don't do a good job in predicting people that are exiting. We only get 51% correct people who are exiting, so the churns. So this is actually giving us the true story. This is not a good model because we are not actually predicting well on the churns. Despite the fact that we have over here at the top 86% accuracy on unseen data, if you check the confusion matrix, it's telling us the correct story. Right, what we're going to do now is that we are going to use smooth library in order to oversample the minority class. So we're going to try and create more data, and this data is going to have more churns in order to train the model again and see if we can get better results. So this is what this mode does. It's basically upscaling the minority class. And then down here, I'm creating a new X train, a new Y train, and then I'm applying smooth.fit resample on my existing X train and Y train. And down here, I'm just using a copy paste of my existing code above. So I'm basically feeding these two new data sets in my new model. And then if we check, we want to check the confusion matrix, which is this one over here. We can see that we have managed to improve exceeded, but it's still random, right? It's still not high enough, so we are not predicting well on people who are churning. Right, moving on, down here I have tried to visualize the whole tree with XGBoost. However, it's not clear and I cannot get it to zoom in. So what I did is that I have trained a new decision tree classifier, and then I have exported the decision tree using graph views that I know that works. So if I run this, it's easier for us to visualize the tree, as you can see over here. And the way it works is that it splits the data based on a variable, and the most important variable is the number of products. So it's saying if the number of products is equal or less of 0.334, then it's going to come down here. If it's less than 0.333, then it's going to come down here, and you can read how the decision tree works. I just wanted to visualize it, but I couldn't get the XGBoost to work. That's why I did the simple decision tree classifier just to visualize it. Next, what we're going to try and do now is that we are going to try and loop through all these parameters we have over here, these hyperparameters, and see if we can actually improve our results. So first we initialize our classifier, and then we are using randomized CV search in order to go through all the possible combinations and see if we can actually improve our results. So if we click run over here, by the way, the rest of the code is the same as above, it's a copy paste. All I have added is this randomized CV search. Then I scroll down here, predictions, training and testing accuracy, printing it. Yeah, let's check. So we have 95% on training, 85% on testing. We have feature importances. And then if we check our confusion matrix, you can see that we did not really improve our model. It's still terrible. We are not predicting well on exceeded. If we go back now and maybe change the evaluation metric to area under curve, I mean, I still think log loss is the best, but let's check if the different evaluation metric makes a difference. Actually, over here in the randomized CV search, I have used a scoring system of F1, which takes into account the precision and recall, which is what we need. And let's check now the confusion matrix. No, still 0.56. So we are not able to improve this model. Now, there is a few things we can do to try and improve our model, but they are going to take time. We can try and eliminate more outliers maybe, or we can try and run a model per geography or per tenure. Try and break it down basically to see where we are predicting well and where we are not predicting well. However, for the purposes of this video, I'm going to stay with this model, even though it's not predicting very well on exceeded, and move on to create the app and the dashboard. However, I wouldn't suggest that you should go on and deploy any model that does not have any good performance metrics, which is actually the case a lot when you're working as a data scientist. You are going to develop a lot of models that are not going to have good performance, and you're going to have to go back to the business and explain that you have used X, Y, and Z and you couldn't get the model to predict well. Right, down here, I'm just storing my model and our results. So first, I am adding the predictions back to the original data set. So this all DF prediction is basically predicting in all of our data set. If I search for it quickly, there you go. You can see it's predicting on X, which is actually all of our data set. And down here, I'm just storing it back into our original data, so we can then take it into Power BI and use it. And down here, I'm just storing the predicted probability, which is basically a percentage, which again, we are going to use in our dashboard. This is the prediction probability over here. Next, I'm exporting this in an Excel file. Next, I am storing the feature importances. So first I round them to 4 decimals, and then I'm storing them into this Excel. And down here, first I save our best model into this file over here. So if I check my files quickly, there you go, you can see is this Kaggle file over here, which is the model we're going to use in the Streamlit app. And I'm also saving our scaler, because after the user makes their selections over here, we have to scale our data again, because that's how we have trained our model, on the scale data. Going back, and the file is called scaler.piggle, and it's basically this file over here, scaler.piggle. Right, the next step now is to create our Streamlit app from scratch. However, I'm going to leave this for the next video, as this video is actually long enough. Right, so I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos.